Hello. In this video, I will show you how to implement VLSM in Cisco Packet Tracer. And for the implementation of VLSM, we will going to use the static routing protocol, how to configure that. Okay, so in this video, I will show you all the details. Okay, so let me first give you the example VLSM configuration, which we will going to implement in Cisco Packet Tracer. First of all, I will show you the parameters that is given here. So we have three end devices, and as obvious that the three end devices are on a different subnet. And if you see here, the IP address corresponding to all the end devices are showing in this particular table. So corresponding to IP address, subnet mask is also given, and the default gateway is given here. Okay, so as we know that for the implementation of VLSM, first we have to calculate that what would be the suitable subnet mask that we have to give to that particular subnet. So as we know that in a VLSM, as per the requirement of the host for each of the subnet, we have to like calculate the subnet mask, and we have to specify the range of the IP address that we have to give to each of the subnet. So this particular example directly, this is what is the value that we have to configure. So I'm not going to give you all the details that how what is the requirement of the host to be configured for this particular subnet. So I'm not giving that thing. So we have already done that in a class. So this particular video is made for giving you that how to implement the VLSM in a Cisco Packet Tracer. Okay, so I will also show you that what is the design of that network topology. So if you see here, so this particular, if you see here, this is a wrong. It is actually is 192.168.10.1. So I have taken this example from gigs for gigs. So if you see here, so PC0, PC2, and PC4. So if you see, these are the three end devices, and these three end devices are on a different subnet. So if you see here, this is one subnet, this is second subnet, this is third subnet, this is the fourth subnet, and this is the fifth subnet. So if you see here, this particular label is actually is representing that what is the default gateway of this particular subnet. Similarly, this is also is giving the specification of default gateway for this particular subnet, and so on and so forth. Okay, so if you see here, the 192.168.10.2 is the IP address of this particular PC. So this when we configure the PC, we have to configure the default gateway as well. So default gateway will be your 10.1, one means 192.168.10.1. So obviously the network ID of this particular subnet will be on a pattern of 192.168.10.0. Okay, and but here it is not like that. It is specifically a class C address. So if you see here, the subnet mask for the subnet will be, first subnet will be 192.224, second subnet is 224, and the third subnet will be 254. So you have to be very careful while specifying the subnet mask. Okay, and if you see here, this particular, this 101, 102. So this is what is the IP address of this particular your port, and 10.102 will be the port address of this particular your interface. Okay, similarly 105 for serial 3 oblique 0, and 106 for this serial 3 oblique 0 for this router. Okay, so first we will design this, and later on I will show you how to configure the network. So let's start. So let me first go on to the Cisco Packet Tracer, and as per the requirement, so first we have to like drag the PC, and then we will create the subnet. So let me first uh, go on to the PC. And then I will to use the switch for creating the LAN, and then I will use the router. So you can use the PT router here, or you can use any of the router. But please see that whenever we connect the two routers, it is good to use the serial communication. So PD router is having that serial communication interface, so we will not have to add any serial communicator on a router. So I have taken directly the PT router, which is having that serial communicator. So let P2 connect. So just see here that automatically it is taking that serial communication. So this design, so I will also label so that while configuring, I will get the idea that what is actually the information. Okay, so 192.168.1.2. So I think that here the network ID will be 192.168 dot. It is 10.2. It is 2 now, so 10.0. Okay, and let me also write the subnet mask here. Subnet mask is 255.255. Subnet mask 255.255.255.192. Similarly, this is what is the network ID. Network ID and the subnet mask to be used. So I think that it is 65. So this will be your 64. And then the subnet mask will be your 224. So this will be the 224. Okay, and then 64, then it is 97. So this will be 96. Paste, and this is what is 96. And then the subnet mask is 252. It's 252. Okay, and so this is what is the description of the subnet. And as we know that if the network ID is 10.0, so it is good to give the first address, which is what will be 192.168.10.1. And this 10.1 must be given to, like as per the design principle, it is good to give 10.1 to this default gateway. Okay, and then 10.2, the next address will be assigned to PC0. So this design principle will be followed for each of the subnet. Let me give the network address of this subnet and this subnet as well. So that uh, okay, so this is what is 101, 102. So definitely the subnet address of this particular network will be 100. 192. Yes, 192. Is this 100? And this one will be your 105, 106. So It is your 104. 104. And I think the subnet mask for this is so 252, and then will be your. So I guess this is subnet mask is not specified here. So we can take the clue from this only, that what will be the subnet mask of the network. So let me check for 100. This is what is 252 subnet mask. So we will give for this, we will going to give 252. So 252. This is also 252. I think, let me to check. So I think that 105, 252. Okay. So yes, in this particular example, we have not calculated that. We know how to calculate. So here in this particular implementation, I have given direct example, and this is what is the design. So now the design is complete, but it will not going to work. As we know that we have to configure. So first, let's start with from the left side. So we will start with PC0. Okay, so PC0 IP address will be your 10.2. Okay, and the subnet mask is 0.192, and the default gateway will be 10.1. Okay, so PC0, so go on to this configuration, go on to desktop and then IP configuration. So IP address will be 192.168.10.2. Okay, and the subnet mask will be, please careful about the subnet mask. So it will be your 0.192, and then the default gateway will be 192.168.10.1. Okay. So this is what is the IP address of this particular your interface. Okay. Then next, so PC0 is done. So we will go on to this router. Okay. So I am always use the principle that always start from left, and then one by one I have I am configuring the thing so that the things will not skip, things will not miss. Okay, so first I will go on to the router 6, and then after that I will go on to the configuration, and as per the label, this interface is labeled as FA0/0. So click on to FA0/0. First thing we have to do is that uh, the port status to be on, and the IP address will be your 192.168.10.1, and the subnet mask will be your 190.192. Okay, so this is what is the will be the configuration is configuration of FA0/0, and the next configuration we will do is about the serial 2/0. So serial 2/0. So as per the label, I can say that the IP address to be taken for configuring this serial 2/0 will be 10.101. Okay, so serial 2/0. Let me to enable this port, and then IP address will be 192.168.10 point your 101, because it is 100, network ID is 100. So the next address will be your 101. So 101 will be given to this serial 2/0. So subnet mask is will be your 252. Okay, so this is done. So let me to close. Next will be your PC1. So I will take first configure the PC1, and then later I will configure this router. Okay, so again go on to, okay, so as per the label I can say that 192.168.10 point point. So network ID is 64, 65 will be this port, so 66. So the IP address will be 66. Subnet mask is given as 224. And yeah, the default gateway will be your 192.168.10.65. So 64 is network ID, 65 is this, and for this PC, this will be the default gateway. Okay, so PC1 configuration is done. Close this. Now I will go on to this router. So if you see here, this router is having three interface: serial 2 oblique 0, FA 0 oblique 0, and serial 3 oblique 0. Okay, so one by one we will configure that. So first we will configure serial 2 oblique 0. So serial 2 oblique 0, click on to serial 2 oblique 0, enable this port, and the IPv4 address will be your. So 100 is the network ID, 101 we have already given to serial 2 oblique 0. So the next address will be 102. Okay, so 192.168.10.102. And subnet mask is your 200 and 252. Okay, so this is done. Serial 2 oblique 0. Then we will configure this FA 0 oblique 0. So actually I use this principle so that nothing should be skipped. Okay, because once if I skip anything, then definitely the topology will not going to work. Okay, so that is why. So serial 2 oblique 0 I have first configure, then FA 0 oblique 0, and later on I will configure serial 3 oblique 0. So FA 0 oblique 0, enable the port. IPv4 address will be your 192.168.10 point your. So it is 64. So this will be 65. Okay, as per the design principle. So, and we know that this subnet mask, the subnet mask of this subnet is your 224. So I have to like update here 224. And I think this is done. And then now I will go to configure this serial 3 oblique 0. So click onto this, enable the port, and then IPv4 address will be your. So this network ID is 104. So the next address will be your 105. So we will configure this port to be your 105. So 192.168.10.105. Subnet mask is this. So this is okay. Okay, so Cisco Packet Tracer automatically detected this, but anyway, it is not the correct one. So you have to check, and if it is okay, then you can just use this only. So 252, yes, this is okay. So I think that we have configured this router fully. So just close this. Okay, so if anyone is having any doubt that after configuration also this port is not enabled as green, so don't worry about that. As soon as you configure this port, it will automatically detect and will show you the green label. So now what we do, we will, as per the principle, again go on to the PC2, and then click onto the desktop, click on IP configuration, and then the IPv4 address will be your 192.168.10 point. It is 96, so 97 will be this, and 97, then 98 will be the IP address that 98, no? Okay. 96, 97, 98, 98. And the subnet mask is here as per the given your subnet mask. It is showing 252. So 252. Okay. And then the default gateway will be 192.168.10.105. 10 point, so 96, 97. So 97. Okay. So now it is done. Close this. Okay. So what we will do, we will go on to router 8 now, and then we will configure this in the interfaces of this router. So as per the label, so first, as per my design principle, or every time I follow the rule, first it will be the serial 2 oblique 0, and then later on I will configure FA0 oblique 0. So go on to serial 2 oblique 0, enable the port IPv4 address 192.168.10 point. So 10.104 is the network ID, 105, I have already given to this particular port, so 106. So I will take 106, I will fill the IP address of this particular interface to be 10.106. Subnet mask is, I have to update 252. Okay. And then next will be your FA0 oblique 0. So just see here that as I have already told you, that once you configure this interface, then automatically the Cisco Packet Tracer will change the label. The earlier it was showing red color and now it is showing green color. Okay. So next, I will I will configure FA0 oblique 0. So again, enable the port IPv4 address is your 192.168.10 point. It is 97. Okay. So this is what is 97. Fine. Don't confuse. 96 is the network ID. Okay. And this is what is considered to be the host of this particular subnet. Okay. So FA0 oblique 0 will be, the next address will be 97 as per this specification, and subnet mask 252. Okay. So Cisco Packet Tracer is smart enough to populate this subnet mask to be 252, and it is correct. Okay. Fine. So I think that, yeah, our configuration, okay, till now is okay. And I think that let me to just flow point to point packet, so that I can check that whether it is working or not. And definitely, if when I wanted to flow from PC0 to PC2, it will definitely not work, because yet I have not configured the routing protocol on a router so that the router can take decision where to route the packet. But first I will show you that whether it is working or not point to point. This is what is checking point to point. So this is successful. Nice. Again, I will check for from this router to this router successful. Good. Reason behind that is that I am just checking it point to point. No requirement of implementing any routing protocol on a router to check point to point flow. Okay. Let me to show you. Yes. And now I will show you from PC2 to router 8. I think that, yes. Okay, so everything is successful, but let me to show you that when I just wanted to flow the packet from PC0 to PC2, it will not going to work. Just see here that the status is showing failed, because yet I have not configured any routing protocol on the router. Okay. Now the last configuration, which is what is very important, is about configuring the static routing on each of the router, because we are actually implementing the VLSM, and to implement the VLSM we will use static routing. Okay, so let me to show you that how to configure the static routing on a router. And one more thing, we will not configure the static routing on any of the end devices. Okay, we have to only configure the static routing on the router only. Okay, so let me first show you that what parameters you have to configure for a static routing. So if you see on a RIP, And definitely one thing that we will not going to use the routing information protocol, which is what is a RIP, to configure the VLSM. Okay, RIP will not going to work on a VLSM. Okay, so we have to go with the static routing for a VLSM. And if you see here, three parameters that we have to know while configuring the static routing on a router. One is the network, which is what is the network ID. Second is the subnet mask corresponding to that subnet. And third is a very important factor, which is what is a next hop. It means that, let us suppose that, let me give you one example, that let us suppose that PC0 wants to communicate with PC2. So definitely when the packet flow from PC0 and reach to this router, first this interface and then later on this interface, then this router like have to decide that this packet will flow to what will be the next hop for that packet. So definitely for this router, the next hop will be this hop. Similarly, for this router, when the packet need to flow to this subnet, so for this router, the next hop will be this interface. And for this router to go on to this subnet, definitely for this router, the next hop to go on to this subnet will be here, this interface. Okay, so this information you have to like configure while configuring the static routing. Okay, so let me to configure this router 6. Okay, so this router 6 is connected to this network and this network. Okay, let me to show you that I will not going to configure this network and this network on this router. Reason behind is that router itself has populated this information in its routing table and specified this network to be a directly connected network. Okay, but this router doesn't know anything about this subnet, this subnet, and this subnet, and this subnet. So definitely we will not going to configure this network and this network. Okay, let me to show you. Okay, so I have to like come out from this config environment, because I have not to configure anything here. I just want to execute one command, which is what is show IP root, which is what will give you the routing table. And just see here that, as I have already discussed, that I need not have to configure for this network and this network, because it is already populated here in a routing table of this router. So if you see here 10.0 and 10.100, so it is directly connected. Okay, so CC specify that it is connected, it is directly connected. So I need not have to re enter this information on a routing table. Okay, okay, so now as I have already told that this network and this network, there is no information about .64, .104 and .96 on this router. So I have to manually, I have to add this network. Okay, so go on to this config, and Cisco Packet Tracer is giving us a provision to use the GUI to directly configure the static routing information. Okay, so the first network I will going to add on this router is so as per the principle, this is already is added. So I will configure first this network. Okay, so 192.168.10.64. Okay, 64, and then mask is 255 .255 .255 .224. Okay, and the next hop. Next hop is the IP address of this interface. So this is what is 192.168.10.100. It is not 100, it is the network ID. So the IP address of this particular serial 2/0 is what? This is what is 101. This is 102. Okay. So yeah, it is 102. So just see here that I need not have to like label this interface, because as I know, as per the design principle, if it is 100 network ID, then definitely 101 is this interface IP address and 102 definitely is the IP address of this particular interface. So next hop is 192.168.10.102. Okay, so this is the IP address of this particular interface. Fine. So add this. Fine. So this network is added. Now the next network will be your 10.104. So just 104, add 104, and the subnet mask of this network is 252. Okay, and the next hop, definitely the next hop to reach to this network definitely will be serial 2/0, because this router only knows the interface address of this particular interface only. Okay, so 102, this is okay. Again, add this. Fine. And then the last network that we have to add onto this router is 96. So add 96 network. Okay. So mask is same 252, and again the next hop is 102. So add this. Okay. So just see here that, yeah, fine. I think that this is okay. Uh, okay. So let me to just close this, and now I will configure for this router. So this router, so if you see here, this router, uh, this network is directly connected to this router. This network is directly connected to this router and this network. It means that out of total 1, 2, 3, 4, and 5, I need not have to configure for this three, but this is out of reach of this router, and this is also out of reach of this router. So I have to manually configure for this network and for this network. Okay. So again, go on to the static of this router 7. So the first network I will going to add on this router is 192.168.10.0. Mask is your 255.255.255.192. And the next hop. Okay, so the next hop to reach to this network, this router is connected to this router, and definitely to reach onto this network, this router have to use the next hop as serial 2/0. So next hop, and what is the IP address of this serial 2/0? So as per the label, 100 is the network ID of this network. So 101 is the IP address of serial 2/0. So directly I am adding 168.10.101. Okay, add this. Okay, so this network have added, and now I will add this network 10.96, and the mask will be your 252. Okay, and the next hop. So for this router to reach to this network, so definitely this router is directly connected to this router. So the next hop to reach to this subnet is this serial 2/0 is used. And what is the IP address of this serial 2/0? As per the specification, 104 is the network ID of this subnet. So remember that, recall that we have used 105 to configure this port. So 105 is this. So 104 106 will be is actually the configuration for this serial 2 object 0. So it is what is 106. Fine, 1045 and 106. Fine, so add this network. Okay, so I'm done with this router 7. So last router is router 8. And yes, for router 8, this network is known to router 8. This network is known to router 8 as these networks are directly connected to this router. But the rest three network is out of the scope or out of the range for this router. So we have to add this network, and this network. Let's start. So go on to the static again. So let me to start with this. Okay, 10.64. So add this network 192.2.10.10.64. Okay, mask is 255.255.255 is 224. Okay, because this just see 224 and the next hop. Okay, for this router only knows this router. Okay, and if you see here, in order to reach to this network, obviously router 8 must need to flow the packet which will reach on to this particular interface. So the next hop for this router definitely will be your serial 3 oblique 0. And just remember, recall that 105 is the IP address of this serial 3 oblique 0. So 192.168.10.105. Add this network. Okay, and then yeah, 64 is added. Next will be your 10.1000. As you know that I always follow the design principle. So 100 is the network ID. Yeah, so network ID 10.100. Fine, and the subnet mask is 252. Okay, and next hop for this router again will be your 105. Okay, so because as you know that in order to reach to this network, obviously it will go via this interface. So this will be considered to be the next hop for this router 8. So 105, I think that this is also is okay. So network address add. And then 10.100 we have added, and the last network that we have to add is 10.0. Subnet mask is 192, and again the next stop is same 105. Okay, again just wanted to again have to repeat the same statement that in order to reach to this network, this router have to flow the packet via this interface. Okay, so this is what is serial 3 oblique 0 having an IP address of 105. Okay, so add this. So I think that okay, so now before checking that whether the now the configuration is okay or not, because we are done with the configuration, and before pinging or before just flowing the packet from one PC to another PC, one thing that it is good to check is that check the routing table of each of the router and check whether each of the router is containing the total network or not. Okay, so as we know that the total number of network we have in this particular infrastructure is 1, 2, 3, 4, and 5. So calculate that whether each of the router now has 5 network information in its routing table or not. Okay, so again go come out from this configuration. Okay, now I just have to like execute the command show IP route in order to check the routing table. Okay, so check first S. So just see here that S stands for static, and as I've already told you that in this to implement the VLSM, here we are using the static routing protocol. Okay, so just check 1, 2, 3, 4, 5. Yeah, 5 network is added in this routing table. And please check whether every of the network like 10.0, yes, 10.64, yes, 10.96, yes, 10.100, good, 10.100, 104. Very good. So I think that this is okay. Close this, go on to this router. Okay, again, go on to the CLI, exit from this configuration mode and execute show IP route. And again, check 1, 2, 3, 4, 5. Yes, 5 network is added here. Again, check 10.0, 10.64, 10.96, 10.100, 10.104. Good. And if you see here is directly connected, and via is also this particular routing table is also showing the information that what is the next hop to reach to this network, to reach to the network. Okay, and lastly, last router CLI. Okay, and show IP route. I think router 8, 1, 2, 3, 4, and 5 network 10.0, 10.64, 10.96, 10.100. Yeah, I think that this is all okay. And one more thing, student. So most of the time you directly actually flow the packet from here to here. So it is good to first ping so that it can establish the connection, and later on you can just see the flow of the packet. Okay, so let me to first execute the command ping 192.168.10 it is PC2. I am interested in pinging to PC2, and as per the information, the IP address of this PC2 is 10.97 is this 98. I think it is 98. Okay, now execute this. Yes, it is means that this is what is showing that reply from this PC. It means that it is completely, it is okay, the configuration is okay, and that is why we are getting the reply from this PC2. Okay, now you can see the, now you can flow the packet and can see that whether it is showing the successful status or no. Just see here that it is now showing successful status while flowing the packet from PC0 to PC2. Okay, and let me to check. So here I am just testing that whether directly, so PC0 to PC1, it is showing the successful status. It means that now this particular network infrastructure is properly is connected and properly is configured, and now any PC can interact with any of the PC of the other subnet. Okay, so thank you very much. Please implement this in your own Cisco Packet Tracer, and you have to share your Packet Tracer and successful configuration status to me. Okay, and LMS. You have to upload this on LMS. Thank you.